गुड मॉर्निंग टू ऑल. लास्ट लेक्चरमध्ये वायरलेस नेटवर्क टेक्नॉलॉजी त्यामध्ये आपण ISM बँड जो असतो ठीक आहे त्याचे जे फ्रिक्वेन्सी त्या आणि मॅक्स सब लेयर त्या ठिकाणी स्टडी केलं होतं. त्यामध्ये डिस्ट्रीब्युटेड कोऑर्डिनेशन फंक्शन्स अँड फ्रेम एक्सचेंज टाईमलाईन त्या ठिकाणी आपण बघितले होते. तो नेक्स्ट पॉईंट येतो आपला नेटवर्क ॲलोकेशन वेक्टर. ठीक आहे. आता नेटवर्क ॲलोकेशन वेक्टर म्हणजे काय? द क्वेश्चन हिअर इज how do other stations refrain from sending their data when one channel is already transmitting? क्वेश्चन काय आहे की जे अदर स्टेशन्स आहे ते कशा प्रकारे रिस्ट्रेन्स होईल. ठीक आहे. सेंडिंग देअर डाटा वेन वन चॅनल इज ऑलरेडी ट्रान्समिटिंग. एक चॅनल जर ट्रान्समिट होत असेल तर त्या ठिकाणी कशा प्रकारे रिस्ट्रेन होईल स्टेशन. तर in other words, how is the collision avoidance is practically accomplished? The answer to both these questions is a special feature called as NAV. NAV means network allocation factor. The concept of NAV, that is network allocation factor, is as follows. When station is sent as RTS frame which consists of the time duration for which a needs to use the channel, the stations which are affected by the transmission create a time called as NAV. The NAV will indicate the amount of time that must pass before these stations can check again whether the channel has again become ideal. This happens every time when a station sends its RTS frame, the other stations will initiate their NAV. During the NAV interval, two other stations will initiate its transmission. In this way, the collision avoidance aspect of the CSMA or CA protocol is accomplished. The other stations check the channel for idleness only after the expiry of the NAV. ठीक आहे. तर त्या ठिकाणी काय आहे, ज्यावेळेस आपण एखादे चॅनल आहे त्यामधून डाटा जर ट्रान्समिट होत असेल ठीक आहे तर ते कशा पद्धतीनं ते स्टेशन रिस्ट्रेन होतं किंवा सेंड करतो तो डेटा त्यासाठी काय सांगितलं आहे एक नॅव कॉल्युजन एक नेटवर्क ॲलोकेशन फॅक्टर त्या ठिकाणी यूज करतो आपण. ठीक आहे. कन्सेप्ट यूज करतो ज्याला आपण त्या ठिकाणी नेटवर्क ॲलोकेशन फॅक्टर असं म्हणतो. ह्याच्यामध्ये काय सांगितलं ज्यावेळेस RTS फ्रेम त्या ठिकाणी सेंड होते जी टाइम ड्युरेशन्स मध्ये कन्सिस्ट होते. जो चॅनल यूज करतो द स्टेशन विच अफेक्टेड बाय द ट्रान्समिशन क्रिएटेड टायमर कॉल्ड ॲज नॅव. तो नॅव यूज करून आपण काय इंडिकेट करू शकतो अमाऊंट ऑफ टाइम दॅट मस्ट पास बिफोर दी स्टेशन्स कॅन चेक अगेन. आता ही जी प्रोसेस आहे ही त्या ठिकाणी कंटिन्युअस होते प्रत्येक वेळी होते. ठीक आहे. ज्यावेळेस स्टेशन काय करतो त्या ठिकाणी RTS फ्रेम त्या ठिकाणी सेंड करतो. The other station check the channel for idleness only after the expiry of their NAV. The next point is म्हणजे collision during handshaking. Our next point is collision during handshaking. If the collision takes place when the RTS and CTS frames are in transitions, then it is called as collision during handshaking. In such a situation, two or more stations try to send the RTS frame at the same time, which may collide with each other. But in CSMA or CA, there is no mechanism to detect such collision. So, the collision of RTS frame also will go undetected. Then how will the sources know that a collision has taken place? Well, a source will assume that the collision has taken place if It does not receive the CTS frame from the receiver in response to RTS. In such events, the sender applies the backup strategy and tries after sometimes. This is how the collision during handshaking is handled by CSMA or CA in the wireless environment. Collision during handshaking म्हणजे काय? एक कॉलिजन त्या ठिकाणी क्रिएट होतो ज्यावेळेस जो आपलं बेस स्टेशन असतं किंवा मग जो हँडसेट असतो त्या ठिकाणी हँडशेक होतो. ठीक आहे. When RTS and CTS frames are in a transitions, then it is called a collision during handshaking. In such a situation, two or more stations try to send the RTS frame at the same time, which may collide with each other. But the CSMA or CA, there is no mechanism to detect such collision, so the collision of RTS frame also will go undetected. Then how will source know that a collision has taken place? Well, a source will assume that the collision has taken place if it does not receive the CTS frame from the receiver in response to RTS. In such events, the sender applies to backup strategy and tries to sometimes. This is how the collision during handshaking is handled by CSMA or CA in the wireless environment. Now, next point is hidden stations problem. Let's see now how CSMA or CA avoids the hidden stations problem. Refer figure. Actually, the RTS and CTS frames and shakes frames are used to solve the hidden stations problem. Note that the PCF is implemented on the top of the DCF and used mostly for those applications that are time sensitive. The access method used by PCF is the centralized quantitations free polling access method. The polling for stations that can be polled is performed by the AP. These stations, when polled in a sequential manner, will send their data to AP on one by one basis. One more interface called PIFS has been defined to give priority to PCF or DCF. This interface PISF is shorter than DIFS. The meaning of this arrangement is that if at the same time a station wants to use DCF and an AP wants to use PCF, then the priority will be given to the AP. But the effect of this higher priority of PCF over DCF is that the stations using DCF may never get the access to the common medium. But this should be avoided, hence the repetitions interval has been designed in order to cover the PCF, that means contentions free, as well as DCF, that means contention based traffic. The repetition interval always starts with the special types of frame called beacon frame. The repetitions frame is repeated continuously. As shown on hearing the beacon frame, the stations start their nav for the durations of the continuous free period of repetitions interval. An example of repetitions interval has been shown in figure. The PC, means point controlled, can perform the following operations or any combinations of them during the repetitions interval. 808.11 uses the concept of piggybacking. The PC, means point controller, sets the CF end continuous pre-end frame at the end of the conditions prepared so that the condition based DC traffic stations can use the common medium. Now what is point coordinate functions? That means PDF. Optical access method which can be implemented in the infrastructure network. Infrastructure network म्हणजे काय, वायरलेस लॅन किंवा त्या ठिकाणी AP, but not in the ad hoc network. Not ad hoc network म्हणजे तर WLAN किंवा मग त्या ठिकाणी AP is called as the point coordinations functions. Note that the PCF is implemented on the top of DCF and used mostly for those applications that are time sensitive. The access method used by PCF is the centralized quantities pre-polling access method. जो access method आहे त्या ठिकाणी PCF त्या ठिकाणी सेंट्रलाइज केला जातो आणि कंटिन्युएशन्स फ्री पोलिंग ॲक्सेस मेथड त्या ठिकाणी यूज केले जाते. द पोलिंग फॉर स्टेशन्स दॅट कॅन बी पोल्ड इज परफॉर्म बाय द AP. द स्टेशन्स वेन पोल्ड अ सिक्वेन्शियल मॅनर विल सेंड their data to AP on 1-by-1 basis. One more interframe space called PSF has been defined to give priority to PCF or DCF. This interframe space PIFS is shorter than DIFS. The meaning of this arrangement is that if the same time a station wants to use DCF and AP wants to use PCF, then the priority will be given to the AP. But the effect of this higher priority of PCF or DCF is that the station using DCF may never get the access to the common medium. आता जे एक्झाम्पल आहे रिपिटेशन्स मेथडचं, ठीक आहे, त्यामध्ये त्या ठिकाणी आपण बघू शकतो, ठीक आहे, एक्झाम्पल ऑफ रिपिटेशन्स इंटरवल, ठीक आहे. ॲक्सेस पॉईंट जे आहेत ते त्या ठिकाणी या प्रकारे दाखवलेले आहेत. पोल स्टेशन दाखवलेले आहे, ऑदर स्टेशन्स, ठीक आहे. अँड B means beacon frame and CF means conditions free. This should be avoided, hence repetitions interval has been designed in order to cover the PCF conditions free as well as DCF, that means conditions based traffic. The repetition interval always start with a special type of frame called beacon frame. आता beacon frame त्या ठिकाणी डायग्राम मध्ये शो केलेली आहे. B जो आहे beacon frame, the repetition frame is repeated continuously. त्या ठिकाणी repeated frame त्या ठिकाणी continuously repeat होत असते. On hearing the beacon frame, the stations start their nav for their duration of the continuous free period of repetitions interval. An example of repetition interval has been shown in figure. The point controller, ठीक आहे, point controller जो आहे तो त्या ठिकाणी can perform the following operations of any combinations of them during the repetition interval. 802.11 uses the concept of piggy banking. The PC means point controller sends the CF end continuation pre-end frame at the end of the continuation free period so that the continuation based stations can use the common medium. आता ठीक आहे, या फिगरमध्ये त्या ठिकाणी रिपिटेशन इंटरवल त्या ठिकाणी शो केलेली आहे. Now our next point is fragmentation. In the wireless communication, the frames often get corrupted because the wireless environment is extremely noisy. The source has to transmit the corrupt frame. Therefore, the fragmentation process, which is the process of dividing the large frame into small ones, is recommended by the protocol. This is because in the event of corruptions, the retransmission, it is always better to send a small frame than a big one. फ्रॅगमेंटेशन्स म्हणजे काय, जे वायरलेस कम्युनिकेशनमध्ये जे फ्रेम यूज करतो आपण, द फ्रेम ऑफन गेट करप्टेड. फ्रेम जे असतात त्या नेहमी त्या ठिकाणी काय करप्टेड होत असतात, ठीक आहे, बिकॉज द वायरलेस एन्व्हायरमेंट इज एक्स्ट्रीमली नॉइजी. जे वायरलेस एन्व्हायरमेंट असतं त्या ठिकाणी नॉइजी असतं, ठीक आहे. द सोर्स हॅज टू ट्रान्समिट द करप्ट फ्रेम, द सोर्स हॅज टू रिट्रान्समिट द करप्ट फ्रेम. जी करप्ट फ्रेम असते ती त्या ठिकाणी सोर्समार्फत रिट्रान्समिट केली जाते. Therefore, the fragmentation process, which is the process of dividing a large frame into small one, is recommended by the protocol. This is because in the event of corruptions and retransmissions, is always better to resend a small frame than a big one. Next point is expose station problem. Earlier in this chapter, the problem of hidden stations and its remedy has been discussed. The exposed stations problem is a similar problem. In this problem, a station refrains from using the common even when no other station is using it. The channel is actually free. In order to understand this concept clearly, refer figure where A is sending stations and B is the destinations. A is sending data to B. Station C wants to send its data to station D, and it is possible to do so without interfering in the communications between A and B. As shown in figure, station C is in the range of station A. In other words, C is exposed to A, so C listens to what A is transmitting and decides to refrain itself from sending its message to D. This causes wastage of channel capacity. The handshaking message RTS and CTS are not helpful in solving the exposed stations problem. In fact, station C refrains itself when it hears the RTS message from station A. This happens because station C does not know the communications between A and B does not affect the zone between C and D. Now let's see the diagram of exposed stations problem. ठीक आहे, आता एक्सपोज स्टेशन्स प्रॉब्लेम म्हणजे काय, जे स्टेशनमध्ये जे प्रॉब्लेम येतात एक्सपोज टाईपचे, ठीक आहे. अर्लियर इन दिस चॅप्टर द प्रॉब्लेम ऑफ हिडन स्टेशन बघितलं आहे आपण, ठीक आहे, अँड द रेमेडी हॅव बीन डिस्कस्ड, त्याच्यावर रेमेडी पण बघितली आपण. द एक्सपोज स्टेशन्स प्रॉब्लेम इज अ सिमिलर प्रॉब्लेम. जो स्टेशन जो प्रॉब्लेम आहे तो हिडन स्टेशनशी रिलेटेड आहे किंवा त्याचे सिमिलर आहे. In this problem, a station refrains from using the common even when no other station is using it. आता जी डायग्राम आहे त्याच्यामध्ये तुम्ही बघू शकता, ठीक आहे, एक स्टेशन ए आहे याच्यामध्ये आणि स्टेशन बी आहे. ए जे स्टेशन आहे ए त्या ठिकाणी काय करतो, सेंडिंग स्टेशनचं काम करतो आहे, आणि बी जे आहे त्याची डेस्टिनेशन्स आहे म्हणजे बी रिसिव्हर आहे. ए सेंडिंग डाटा टू बी, ए त्या ठिकाणी बीला डाटा सेंड करतो. स्टेशन सी जो आहे तो त्या ठिकाणी स्टेशन सी वॉन्ट्स टू सेंड इट्स डाटा टू स्टेशन डी. सी त्या ठिकाणी डीला डाटा पाठवू इच्छितो, ठीक आहे. and it is possible to do so without interfering in the communication between A and B. आता A आणि B यांना डिस्टर्ब न करता त्या ठिकाणी तो डाटा सीकडून डीकडे ट्रान्समिट करायचा. त्या ठिकाणी काय करू शकतो आपण, स्टेशन C इज द रेंज ऑफ स्टेशन, इन अदर वर्ड C इज एक्सपोज टू E. C काय करेन त्या ठिकाणी Aला एक्सपोज करून. सो C listens to what A is transmitting and decides to refrain itself from sending its message to D. या प्रकारे एक्सपोज स्टेशन प्रॉब्लेम त्या ठिकाणी सॉल्व केला जातो. The handshaking message RTS and CTS are not helpful in solving the exposed station problem. In fact, station C remains itself when it hears the RTS message from station A. This happens because station C does not know the communications between A and B does not affect the zone between C and D. C can sense to D as this area is free, but C erroneously refrains to send because of received